students, this is Madam Hawa in chemistry. Today, our lesson on Form 3 topics, and under this topic or subtopic, endothermic and exothermic reactions. I hope you are happy today to learn about this exothermic and endothermic reaction. Firstly, let me explain to you what is meant when we say exo. Exo means release. And what about endo? Endo means absorb. Therefore, exo means release and endo means absorbs. And the word thermic means heat. Therefore, endo absorb, exo release, and thermic means heat. So, my dear students, who can try to tell me what is an endothermic reaction? Yes, Ali? Oh, good. Thank you very much. Endothermic reaction. Say endothermic reaction. So, this is a endothermic reactions. Yes. In the reaction good. In the reaction good in which heat is absorbed from surrounding, to the reaction. Okay, thank you very much. Therefore, endothermic reaction, this is the reaction in which heat is absorbed from the surrounding to the reaction. And what about exo? Exo? Yes, Amina? Good. Thank you. Therefore, exothermic reaction, this is also the reaction in which heat is released. Instead of absorbed, here is released. Released to the surrounding. Released to the surrounding. Released to the surrounding from what? From the reaction. Thank you very much. So, after knowing the meaning of exothermic and endothermic reaction, is there anyone who can give me an example of the reaction in which heat is released? Who is ready? Yes, you are right. That is burning of matches. Oh, it's cold. You are right. Burning of matches. This is an example of exothermic reactions. Why? Okay. Thank you. This is an exothermic reaction because you feel heat around it. Once you burn these matches, you feel what? You feel heat around this. Therefore, this to say heat is released to the surrounding from the reaction. Which reaction? Burning of matches. Thank you. Now, look at this picture. Look at this picture carefully. This is a part which shows photosynthesis. It's a photosynthetic plant. So who can you tell me what type of reaction is there? Yes. Very good. This is an example of endothermic reaction. Why you have said that? Is there any idea? Yes, Mariam. Thank you. Yeah, because here we say that heat is absorbed. Heat is absorbed by the leaf. Absorbed by the leaf from the surrounding. By the leaf to do what? To do photosynthesis, in which this heat is used to make food with the help of carbon dioxide and water. Therefore, here is an example of endothermic reaction. The heat was absorbed from the surrounding to the reaction, which is photosynthesis. Okay? Now, look at here. Observe carefully what I'm doing, and then you're going to answer me. I have this one, ammonium chloride. This is ammonium chloride. Have you seen? So, I add water. I add some water in it, to dissolve this. Can you hold this beaker at the bottom? How do you feel? Oh, it's cold. It's so cold. Okay. Who can tell me? What type of reaction is this? It's too cold. What type of reaction is this? Yes. Mohammed. Oh, good. Thank you very much. This is an endothermic reaction. It's an endothermic reaction. Why? Who can tell me why this is an endothermic reaction? Very good. You are right, my dear. Because heat is absorbed in the reaction, and here we feel cold. This is to say, during endothermic reaction, the environment becomes cold. Therefore, dissolution or dissolving of ammonium chloride in water is an example of endothermic reaction. Okay, now I have water. Carefully, water. Water. I hold the beaker. I feel normal. Neither hot nor cold. Can you do that? Okay. So now I have this one, conch sulfuric acid. Conch sulfuric acid. I add conch sulfuric acid in water. Can you hold, my dear? Can you hold? Oh, how do you feel? I feel, oh, it's too hot. It's too hot, right? It's too hot. Who can tell me what type of reaction is this? What type of reaction is this? Yes, Zubaida. Good. This is an example of exothermic reaction. This is the illusion of conch sulfuric acid in water is an example of exothermic reaction. Why? example of endothermic reaction? Yes. Because once we hold this beaker, we feel hot. It's too hot. This is to say the heat is released. The heat is released to the surrounding from our reaction. And we know that in exothermic reaction, the heat is released to the surrounding. That's why the surrounding becomes hot. Okay, thank you. So, furthermore, the scientists went further to express exothermic and endothermic. Here, I have this one. Look at this. This is the energy profile for exothermic reaction. Let us see the features under this profile. First, as usually, we have two axes. We have energy, in which here, let's say energy in kilojoules. And then this side is the time of reaction or reaction pathway, right? Therefore, here we have reactant. This is the energy of the reactants before reacting. And here is the energy level for the products after the reaction taking place. Here, by using this line of energy, we see that on the reactants, the energy level of the reactants is higher than the energy level of the product. Suppose here we have A and B reacts to form C and D. Who can tell me why the energy is much less in product than in reactants? You can try to say something. Why we have much less energy in the products compared to the reactants? Okay, because here we have an exothermic reaction, and we know that in exothermic reaction, the heat is released to the surrounding. So before A and B was this amount of energy, but after the reaction, some of the energy are within C and D, that is our product, and because our reaction is exothermic, therefore the other energy or the other form of energy in the form of heat is released to the surrounding. That's why we have much less energy here. Thank you very much, my dear students. So let us see another energy profile. Another energy profile. This is the energy profile for endothermic reaction. What can you say on the difference of energy from reactants and products? The same way here we had A reacts with B to form C and D. Why the energy is different now? And why the energy of the product is this one and the energy of reactant is less? Yes, thank you very much. Yes, here because the reactant, we know that as the reaction is endothermic, and we know that in endothermic reaction, the energy from the surrounding is absorbed to the reaction. So before, this was the energy of the reactant before producing the product. But after forming the product, this energy, which is within A and B, produce or attained by product C and D, plus the energy from the surrounding. That's why here we have much more energy in the product side compared to the reactant side. And this is what we call endothermic reaction. And this is the difference between endothermic profile and exothermic profile. That is, we have much less energy in product in a profile of exothermic, and we have much more energy in the product in endothermic reaction. And this is because, as you have told me earlier, this is because here energy absorbed from the surrounding. That's why this energy from the reactant plus energy of the surrounding make to have more energy than here. Here energy, some amount of energy which was from the reactants released in the form of heat to the surrounding. Okay, so here compare now between these two profiles. Have you observed any other features we haven't explained yet? Have you observed any features over here? Yes? Oh, okay. A dome shape? A curve shape? Yes. We have here a curve shape or a dome shape. This is to say, each of these, there is something in common. There is something in common in which the energy rise to a certain peak. The energy rise to a peak. So this energy now at the peak is known as activation energy. Known as activation energy. The same case here, we have this peak. Also here is an activation energy. Right? Therefore, we know that before any chemical reaction to taking place, or before the reactant to react to give the product, the molecule or the particle must collide each other. So during this collision, energy is required. That is, particles must have sufficient energy to collide to form the products. So that is the energy known as activation energy. We can define this one, activation energy. Activation energy, this is the minimum amount of energy that the particles must have in order to react. Therefore, all of these you see here, I have A and B. They must reach to the activation energy. Those particles collide each other after attaining activation energy. That's why we have the product. So we have another features in our profile, activation energy. And it is by representing it, this is start from the reactants. This is the energy started from the reactants to the product. This one. Energy from the reactant to the peak. To the peak. These reactants, this is the energy for reactants, and here is the point where there is a peak. Therefore, the difference between these 2 points, we have this known as activation energy. The same features we observe in endothermic reaction. Here we have this one. Also, from the product, here is the reactant, the point of reactant, and here is the peak. Here is the peak. Therefore, here we have also activation energy. It is abbreviated as EA. Okay? Thank you. So, my dear students, let me ask you a question. What are you going to do? Or I can ask you like this: how the burning firewoods help you during cold condition? Oh, good. Okay, we say in the village, we see in the village, during cold conditions, peoples are burning firewoods and revolving that burning firewoods in order to get heat, because they know that that is an exothermic reaction. They feel cold, but once they are around this burning firewood, they get heat, because that is an exothermic reaction and release heat to the surrounding. Thank you very much, my dear students. Today we have learned about endothermic and exothermic reaction. We have said that, okay, endothermic reaction is a reaction, good, is a reaction in which heat is absorbed from the surrounding to the reaction. Thank you very much. And endothermic reaction, exothermic reaction, yes, okay, thank you. Is an exothermic reaction is a reaction in which heat is released to the surrounding from the reaction. And then we have seen the energy profile diagrams. We have seen the features on energy profile diagram, in which in exothermic reaction we have much less energy in products compared to the reactants, whereby we have much more energy in endothermic reaction compared to the reactants. Then, okay, thank you very much for listening, my dear students. So this will be your homework. Okay, this is, my dear students, this is your homework. You're going to do this at home. What type of reaction takes place during the following? During cooking of food. During dissolving of ammonium nitrate and burning of paper. So I want you to write the type of reaction from these processes. Thank you. Thank you for listening, my dear students. Thank you for your participation. Good. See you on the next lesson.